Dear students, today we are going to start with a new chapter, that is Polygon. And the objectives of this chapter are: number 1, meaning of polygons; number 2, types of polygons; number 3, regular and irregular polygons; number 4, properties of regular polygons; number 5, to find sum of all interior angles; number 6, to find angle of a polygon; number 7, to find number of sides of a regular polygon; and number 8 is to find exterior angle. Right? So student, today's video is going to be about the first 4 objectives of this chapter. So let's get started. So students, first of all, we will know what is the exact meaning of the polygon. So here you can see that I have divided the polygon into 2 words, that is poly and guns. Now here poly means what? Many. And guns mean what? Sides. So polygons means many sides. So we will have a definition for polygons, that is polygons are the geometrical figures having many sides. From this word we can make this definition like this: polygons are the geometrical figures having many sides. Or we can say that polygons are the closed figures made up of 3 or more line segments. So I'm repeating it. Polygons are the closed figures made up of 3 or more line segments. Right? So students, now we will talk about the types of the polygons. Right? So students, first of all, you should know about this, that the polygons can be identified on the basis of their sides. Then you can give any name to that particular figure with the sides, right? So here I have made a chart for your understanding, that in the first column I have written here number of sides. In the second column I have made a figure, and third column I have written the name of the figure, right? So first of all, we will have the number of sides. So first here we are having the number of sides are 3. So if I will have number of sides 3, that means which figure we can form with the 3 sides. So you can see here we can have these 3 sides: AB, BC and CA. These are the 3 sides. With these sides we can make this figure. And what is the name of this figure? That is triangle. So this is a closed figure. So this is the shape of a triangle, which is also known as a polygon, right? So just now we have learned about the polygons definition, that is polygons are the closed figure made up of 3 or more line segments, right? So now I think you are understanding the definition as well. So this is a closed figure made up of 3 line segments, right? So this is a triangle. Now move to the another one. So here you can see that there are number of sides are 4. So we will take 4 sides. So here I have taken AB, BC and CD and DA. So here basically 4 sides are there. So with these 4 sides, which shape is forming? This is a shape of a quadrilateral. So again this is a closed figure made up of more than 3 line segments. So there are 4 line segments: 1, 2, 3, 4, right? So this is a shape of a quadrilateral, which is also known as a polygon, right? So now move to the another one. So now here the number of sides are 5. So with 5 sides we will have a figure like this. In this I have taken AB, BC, CD, DE and EA. So that means basically there are 5 sides: 1, 2, 3, 4 and 5. So these are the 5 sides, and with 5 sides we form a pentagon. So a figure with the 5 sides is known as a pentagon, which is also known as a polygon, right? Now move to the another one, that is number of sides 6. So with number of sides 6 we can form a figure like this. So here you can see I have taken AB, BC, CD, DE, EF and FA. So that means there are basically 6 sides: 1, 2, 3, 4, 5 and 6, right? So with 6 sides we have formed here a figure which is known as hexagon. right? So hexagon is called a polygon, right? So move to the another one. So now we will talk about the sides. Number of sides are 7. So with number of sides is 7, we can form a figure like this, right? So here the figure with 7 sides will be called a heptagon. We can also give the naming to the figure. So here you can see I have given the naming as AB, BC, CD, DE, EF, FG and GA. So there are basically 7 sides, and with 7 sides we form a figure which is known as a heptagon, right? So you should remember that the figure with 7 sides is called a heptagon, right? Which is also known as a polygon. Now we will talk about the number of sides as 8. So with 8 sides we can form a figure like this. So which are these sides? AB, BC, CD, DE, EF, FG, GH and HA. So basically these are 8 sides, and with 8 sides we form a figure which is known as octagon, right? So here octa means 8 and gon means side, right? Similarly here hepta means 7 and gon means side, right? So here we have understood that the figure with 7 sides is known as heptagon, or there is one more name for this heptagon which is known as septagon, right? Septa means 7 side, right? So next one is 8. 8 means octagon, right? Now move to the another one. Now there are number of sides are 9. So with 9 sides, which figure we can form? So here we are taking the sides as AB, BC, CD, DE, EF, FG, GH, HI and IA. So these are basically 9 sides, and with 9 sides we are forming a figure which is known as a nonagon. Nona means 9 and gon means side. So it is known as a nonagon, right? Which is known as a polygon as well. Next one is the number of sides 10. So a figure with number of sides 10 will be called a decagon. Deca means 10 and gon means sides. So that means 10 sides. So which are these 10 sides I'm taking here? So first one is PQ, second is QR, RS, ST, TU, UV, VW, WX, XY and YP. So there are basically 10 sides, and with 10 sides we are forming a figure which is known as a decagon. So students, you should remember that the sides, and with these given sides we are forming a figure, and the name of the figure you should remember on the basis of their sides, right? So students, now we will quickly recall about the polygons on the basis of their sides. So here you can see that a figure with 3 sides is called a triangle, a figure with 4 sides is called a quadrilateral, a figure with 5 sides is called a pentagon, and figure with 6 sides is called a hexagon, right? Similarly, a figure with 7 sides is called a heptagon or a septagon. A figure with 8 sides is called an octagon. A figure with 9 sides is called nonagon. And figure with 10 sides is called a decagon. Right? So now students, we will talk about now the diagonals of a polygon. So here I am taking the example for this quadrilateral with 4 sides. Right? So here you can see that AB, BC, CD and DA, these are the 4 sides of the quadrilateral. Now we will talk about what are the diagonals of this quadrilateral. So now when we join the vertices of the figure, or we can see that the corner points with each other. So here you can see that A is the vertices of the quadrilateral, right? So it is a vertex, single will be called a vertex, and the all 4 will be called the vertices, right? So here A point is there, A vertex is there. When we will join this A with C, now AC will become a diagonal, right? Then AC will become a diagonal. Similarly, this BD will become a diagonal. So here you are having the 2 diagonals, that is AC and BD or DB as well, as you want to give a name to the diagonal. Alright? So students, just now we have learnt about the diagonals of a polygon. Now we will learn that how to find the number of triangles containing in a polygon. So here I'm taking the example of this figure, that is pentagon, and you know that in pentagon how many sides are there? There are 5 sides. So you can see here AB, BC, CD, DE and EE, right? So here one formula is there for finding the number of triangles containing in a polygon. That is, here I have written n minus 2. N means what? It is number of sides. So n minus 2. So how many sides in the pentagon? That is 5. So 5 minus 2 you will put on the place of n. You will write here 5. 5 minus 2, that is 3. So that means in a pentagon there are 3 triangles. So how can we identify these 3 triangles? So if I will join this A point with D, similarly this point B with D, so you can see that there are 3 triangles forming. So which triangle are these? So this one will become the first one, this will be the second one, and this will be the third one. So you can also name them as triangle AED. Second triangle would be ADB, right? So first one will be AED and the second one will be ABD and third one will be BCD, or you can say that CBD or CDB. Alright, so this is the way to find the number of triangle containing in a triangle. Alright, so students, now we will talk about the types of polygon, that is regular and irregular polygons. So now here we are having regular as well as irregular polygons. So now first of all we will talk about regular polygons. So basically, what are regular polygons? A polygon is a regular when its all sides and angles are equal. I'm repeating it. A polygon is called regular polygon when its all sides and all angles are equal. So here I will take one example for you people to understand this. So here I'm taking an example of an equilateral triangle. So first one I'm taking here equilateral triangle, that is triangle with sides AB, BC and CA. Equilateral. Equilateral means all sides are equal and all angles are equal. So here I'm taking all sides as 4 centimeter, right? And in an equilateral triangle all angles are of 60 degree, right? So here the definition says that a polygon is regular when its all angles and all sides are equal, right? So here you can see that this is a type of a polygon in which all sides are equal as well as all angles are equal. Then this triangle will be called a regular polygon. All right. Now we will talk about irregular polygon. So now students, here's irregular polygon. A polygon is irregular when its all sides and all angles are not equal. So I'm repeating it again. A polygon is called an irregular polygon when its all angles and all sides are not equal, or we can say they are unequal, right? Now I'm taking here one example for irregular polygon, that is of quadrilateral. So here I have taken a quadrilateral with 4 sides AB, BC, CD and DA. So here you can see that the length of AB line segment is 6 cm, BC is 2.5 cm, CD is 5 cm and DA is 4 cm. So here you can see that all the lengths of the sides are unequal or different, we can say. Similarly, you can see that this angle A is an acute angle and rest of all these angles are obtuse angles, right? So that means all angles are different. So that means this is an example of irregular polygon. All right. Now students, we will talk about the properties of regular polygons. So what are the properties of regular polygons? So we will talk about them one by one. So here number 1 is all sides are equal. In a regular polygon, all sides are equal. Number 2 is all interior angles are equal. So all the interior angles of a polygon or a regular polygons are equal. So next one is all exterior angles are equal, right? So students, you remember the chapter we have done lines and angles, in which we had talked about interior angles as well as exterior angles. So you all know about the interior as well as exterior angles. All right. So here we are having the three properties. Now we will talk about the interior angles as well as exterior angles and the size of a regular polygon, right? So here I have taken one example. So students, you can see here I have taken here one triangle, that is ABC, in which you can see that the internal or the interior angles are given as 60 degree, right? Now, if we will extend these line, that means C line, if we will extend this C line to this point that I have marked with a red color pen, and similarly, if we will extend this side, that is BC, from this point to that point. Similarly, this AC will be extended till here. What will happen? An exterior angle will be formed outside the triangle, right? Now, this triangle will be 120. Now, how it can be 120? Can you please think about this? How it can be 120? Yes, if you are thinking like this, you will apply the property of angles on a straight line by cutting or by subtracting, like 180 minus 60, you will get here 120. So the exterior angle will be 120, right? So here you can see that all the properties are satisfying this. So first one is all sides are equal. So if I'm taking here example of an equilateral triangle, so all sides are equal. Second one is all interior angles are equal. So you can see that all interior angles are equal. Next one is all exterior angles are equal. So here you as well, you can see that all exterior angles, that is 120, 120 and 120, all exterior angles are equal, right? So now move to the another one, that is number 4. So number 4 is sum of all interior angles. So now what is the sum of all interior angles? So here we are having one formula for finding the sum of all interior angles. So it will be equals to 2n minus 4 multiplied by right angle. Right angle means 90 degree, right? Now what do you mean by n? So here I've written where n means number of sides, right? N means number of sides. Now next one is number 5, which is each interior angle. So here you can see that I have written here sum of all interior angles, right? So now we are finding this each interior angle. So for each interior angle, what we need to do, we just have to write this formula here and divide it by n, means number of sides. So next one is sum of all exterior angles. So all you know that sum of all exterior angle will be equals to 360. How it will be 360? So from this figure you can understand 120 plus 120 plus 120, which is equals to 360, right? So sum of all exterior angles will be equals to 360 degree. And number 7 is each exterior angle. Now we have to find each exterior angle. For finding each exterior angle, we have to divide this 360 by n, means number of sides, right? So students, I hope you understood all these concepts regarding the chapter, that is polygons. So what you have to do, you have to revise all these things and all these topics again and again, so that you would be able to do the next topic, that is the application regarding this polygons, right? So now I hope all of you are able to do the related homework that we have sent you in your Snap homework. But before starting your homework, student, please go through YouTube links, because all these links are very helpful for you for solving and understanding these type of concepts. Thank you.